Hey kids, here's where the fun begins. We get to take all those things that we've been talking about with derivatives now, and we get to totally dump that whole long, ginormous limit process and just get right down to the nitty-gritty. So we needed that limit process to understand what was going on, but now we don't have to use it all the time. We've got all these different tricks now that we can use, and we can start putting them into our bag of calculus rules, which is going to grow exponentially, but it's just is going to make life really, really, really nice. So take a few minutes here as we go through this and just look at some of these wonderful things we can do now without having to take a limit. First off, if f is a function that's constant, then the derivative is 0. So if I tell you that f of x is equal to 4, then f prime of x is equal to 0. Remember, we're dealing with rate of change. And if the rate of change is constant, that would be 0. Okay, there's no rate of change. All right? What about the power rule for positive integers of x? Hey, now this is one that some of you guys should have maybe seen or caught a glimpse of somewhere along the way as we've been working, but f of x equals, let's say something really tough like x to the 4th. So if I go x to the 4th and I want to know what f prime of x is, all I have to do is take that 4 that's up in the exponent, put it down here in the front, rewrite my variable, and subtract 1 from 4. We can do that. We're in calculus. So 4x cubed is my new derivative. No more limit process. Gosh, this is great. Well, what about if we have some function u and it's differentiable and c is a constant, then what? Well, that would be something like this. If f of x equals, say, 3x to the 2nd, okay, then we have a constant, and that constant in this case is the 3. So we would just take the 3 times the derivative of x squared. Well, what does that look like? Well, that's a great question. So this would be f prime of x equals 3 times 2x. That 2x is just like what we did a second ago. So what is this really? 6x. Okay? So all we're going to do is take that exponent now and multiply it with the constant in front. Oh, this is so much easier. If u and v are both differentiable and their sum and differences are differentiable, then we add the derivatives. What does that mean? That means if we've got a polynomial, say f of x equals 3x squared plus 7x, the derivative then, we would still just add those up. It's still going to be the exact same thing. So what's the derivative going to be? It's going to be 2 times 3, 6x, just like we had on the previous problem, plus the derivative of 7x. Now, what would that be? Just 7. And these are the first few rules that we're going to have in a long line of rules this year in calculus. And man, do they make life easy.